Hello friends, welcome to my channel MathAlcoholic once again. So in this video I am going to start the completion exercise, which is not although official exercise as it is very much skipped in schools. This is the miscellaneous exercise. As you can see, I'll be starting from question number 1. So let us note that this kind of questions like this as given in this example, we cannot solve this from just by taking some axioms or theorems. Okay, this have to be proven by inductive methods, and here I'll be using mathematical induction, principle of mathematical induction. Why? Because this is the only convenient method and the only method in the scope of your syllabus with which you can solve this kind of problems. Alright, because these are problems by observation rather than problems by deduction. Alright, so let us start with the given data. Given a is equal to 0, 1, 0, 0. Alright, now to prove, let us assume a statement p of n like this, such that ai plus p of a to the power n, that is equal to a to the power n I plus n a to the power n minus 1 ba. Let us assume this statement to be proven as Pn. Alright, now p of 1 is equal to ai plus ba is equal to ai plus n is 1 here, n minus 1 is 0, so this is a to the power 0 into ba, so that is equal to ai plus ba. So we get ai plus ba is equal to ai plus ba. Therefore the result holds true for n is equal to 1. Alright, now let it be true for n is equal to k as well, as this is our technique of mathematical induction. Let us assume it to be true for n is equal to k, and if it holds true even for k is equal to 1, after assuming it holds true for n is equal to k, then it is obviously true for any general n. So let it be true for n is equal to k. Alright, that is pk is equal to which is ai plus ba to the power k is equal to aki plus k a to the power k minus 1 ba. Let it hold true for any k. Hence, for this equation to be satisfied for any integral n, the result should also hold true for n is equal to k plus 1. Alright, now p of k plus 1, let us deduce what this statement is. This is ai plus ba raised to the power k plus 1, or in other words we can split it up like this: ai plus ba to the power k into ai plus ba. Alright, I hope you have no doubt in it. So this gives us a raised to the power ki plus k a raised to the power k minus 1 ba, as we had assumed this statement p of k, and here it is ai plus ba. Now just expand it, you will be getting a k plus 1 I plus k a k b a I plus a raised to the power k b I a plus k a k minus 1 b square a square. Alright, so clubbing this we get a k plus 1 I, and clubbing these two terms we get k plus 1 into a raised to the power k ba, and here plus k a k minus 1 b square a square. Alright, so let us assume this as statement 1 or equation 1. Now you would see that a square is equal to 0, 1, 0, 0 multiplied by itself, which is equal to 0, 0, 0, 0, which gives us a plain 0. So the matrix A square is a 0 matrix. So therefore from 1 Zero matrix multiplied by anything is 0. So we can write that AI plus BA k plus 1 is equal to a k plus 1 I plus k plus 1 a raised to the power k BA plus 0. Okay, as everything multiplied by a 0 matrix is 0. It is basically equal to k plus 1 I plus k plus 1 into a raised to the power k plus 1 minus 1, which is k BA. Okay, which is equal to ultimately p of k plus 1. So you can see that this result holds true for n is equal to k plus 1. Hence it must hold true for all n. Alright, so therefore we are going to write the final statement by the principle of mathematical induction AI plus BA raised to the power n is equal to a raised to the power n I plus n a raised to the power n minus 1 BA, where a is equal to 0, 1, 0, 0 and n belongs to the set of natural numbers. If you want, I can make a different video explaining what principle of mathematical induction is, but that is only on demand request. If demand is more, I will naturally sit for making that. Alright, now let us come to the next question similarly. So question number 2 is basically the exactly same type as of question number 1. Here also we cannot show it directly as there are no as such methods of proof, but mathematical induction makes it a lot easier. So let us start by the given data. Given a is equal to 1, 1, 1, 1, 1. Alright, now to prove Pn, let us assume this result by a statement is equal to 3n minus 1, 3n minus 1, 3n minus 1. Alright, now once again, first we need to show that it holds true for n is equal to 1. If it holds true for n is equal to 1 only, then we will be proceeding by assuming it to be true for n is equal to k, and then we need to show it is true for n is equal to k plus 1 as well. All the 3 steps are necessary here. If you want a detailed explanation, I will make a video on it later. Now, therefore, p of 1 is equal to 3 raised to the power 1 minus 1 so you know 3, that is 3 raised to the power 0, 3 raised to the power 0, and that is basically 1, which is equal to a. Okay, so therefore we can say p of n holds true for n is equal to 1. Now let the result be true for n is equal to k. So therefore p of k is such that it is a raised to the power k, where it is 3 raised to the power k minus 1. Alright, now we need to prove that the result is true for n is equal to k plus 1 as well. Now we need to prove the result is true for n is equal to k plus 1 as well. Now a raised to the power k plus 1 is equal to a into a raised to the power k. Okay, now a we know it is 1, 1, 1, 1, 1, 1, 1, 1, 1, and a raised to the power k we just assumed it to be true. Alright, now see, this is equal to 1 into 3 raised to the power k minus 1 plus 1 into 3 raised to the power k minus 1 plus 3 raised to the power k minus 1 plus 1 into 3 raised to the power k minus 1. Each element is this. Now this is exactly 3 into 3 raised to the power k minus 1. Alright, so this is what we are going to write. Alright, so this will be plain giving us 3 raised to the power k, 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 and so on. Now this is exactly equal to 3 raised to the power k plus 1 minus 1. Alright, so we can clearly see that a raised to the power, that n equal to k plus 1 also holds true. Alright, so hence the result is also true for n is equal to k plus 1. Therefore, by mathematical induction, a to the power n is equal to 3 raised to the power n minus 1, and this will continue, and it is proved. Alright, so in this way you need to do the questions which cannot be proved otherwise by any axioms or theorems. So I hope you have no problem. Exactly in the same way you need to do in board's examination. Now I'll be seeing you in the next video, where I'll be discussing from question number 3 onwards of this exercise. Thank you very much for watching this video.